Alright, in this video I'm going to be explaining polynomials, all about polynomials, yay! Okay, so I'm just gonna go right with the definition that the book gives. A function p is a polynomial if p of x is equal to an x to the n plus a n minus 1 times x to the n minus 1 plus a ellipse plus a 2 times x squared plus a 1 times x plus a to the 0, where a is a constant. These things, well, yes, a is a constant, and when it's next to a variable in a term, it's called a coefficient. So constant slash coefficient. Is it two F's? Yes, it's two F's. Okay. And the degree of the polynomial is the highest degree of the variable, in this case n. Alright, so you might be looking at this and you're probably like, well, what the crud is this? Well, all this giant thing is saying is that this is what a polynomial is. It's a term to the highest degree plus a term minus a degree lower than that, plus plus plus, same things, all the way to a term of degree 2 plus a term of degree 1, technically there's a 1 here, plus a term of degree 0 with there's technically an x to the 0 here, but that's 1. So if there's a constant here, it's just 1 times the constant. So that's why they usually leave out x to the 0 on here, just to make things a little easier to read. Okay, so the graph of a polynomial, well, let me just go right into the domain and range. The properties of polynomial functions. The domain is always all real numbers, or infinity to infinity, negative infinity to positive infinity. And the domain actually varies based on what kind of polynomial function you're given. If your polynomial function is of degree 2, meaning its highest degree is 2, then you have what is called a quadratic equation, or a quadratic formula, or a quadratic function. That's what I'm looking for. So degree 2, everything else doesn't really matter. If it's of degree 3, plus or minus anything else, then it is a cubic function. And then there are higher degrees of degree 4, of degree 5, etc., etc., etc. And I'll briefly draw example graphs really quick just to give you an idea. Actually, we use the same y-axis for each graph. Okay. X squared is a quadratic function, also known as a parabola. Opens up like that. Depending on how you manipulate the leading term or the terms in between, this parabola can move up and down. It can be upside down. It can be all over the place. Cubic function alone is just like that. And based on however you manipulate the graph, this thing too can go anywhere. An example of I'm looking at the book here for an example of a function to the 4th power. It's giving you something like this. Well, actually, I'll do it with the way the book has it centered around the origin. Something like that. It's an attempt at y is equal to x to the 4th minus 3x squared plus x. And then I'm going to attempt 1 to the 5th root. Something like that. That's supposed to be y is equal to 3x to the 5th minus 25x cubed plus 60x. And you could plug these formulas in to see the really correctly drawn graphs. I probably should have brought out Grapher and showed you that. Yeah, I probably should have done that. But as you can see, though, on all these graphs, they keep going left and to the right, to the left, to the right, to the left, to the right, to the left, right. So the domain, this just proves that the domain of polynomial functions is always all real numbers, okay, for each one. And as you can see, too, that the range differs, too, as well, particularly for even functions, because you can see this is an even function, and the range goes from 0 to infinity. This is an odd function. The range is from positive infinity to negative infinity. This is an even, not really even. It has more even than odd. I'm not going to go into how to find whether it's actually it's neither, right? So, but it has more even than odd function or than odd terms. So its range is kind of limited here, as you can see. It's like -2 to infinity or something like that. This is an odd function, and the range is from positive to negative infinity, and that's a little pattern if you see there about even and odd functions and their ranges. Even functions tend to have limited ranges. So that's all about polynomials, and there's one here about reciprocal functions. I'll do that later, but I'll do examples of polynomial functions later as well. So this is really all you need to know for now. Stay tuned for more functions from section 1.2.